Hi, thank you all for joining. This is the Kubernetes SIG Storage Onboarding Initiative. It's a series of videos designed to help you onboard and get started contributing to SIG storage more quickly. Today's episode is about CSI drivers and utilities and will be presented by Luis.
Thank you very much. I just had to get my slides here. I have them ready. I'm going to share my screen now. To add an extension. All right, entire screen. All right, can you see? Okay, you can see my screen now. You can see from my phone.
Yes, I can see your screen.
Okay. Now present. All right. Thank you, Erin, for the introduction. So today we'll be talking about a continuation of Vladimir's presentation, where he presented of what CSI is and how Kubernetes uses it, and you know how it integrates. And now you're probably thinking, okay, so I want to write a CSI driver. What is available for me to use? So we got a set of utilities and drivers to be able to help you with this, be able to make sure that your driver conforms to the spec, and a few utilities to be able to do some testing and such. So let's get started first. We have everything pretty much under the GitHub CSI repo. It's Kubernetes.CSI repo in GitHub, and under that you're going to find quite a few repos. Some of them are about what are called sidecar containers, which are helper containers to be able to integrate CSI drivers into Kubernetes. And then some other ones are about documentation, which we'll go into a little bit, and then the utilities we have here and the drivers. So one of the things here is let's talk about the drivers first. We have a drivers repo right now, which we created when we first started the project, and that drivers repo is really was created as a sample, and it started maturing more and more into more realistic drivers. So there is a issue right here where we are discussing what to do with the drivers repo. So just when you look at it, don't feel that this is the way we're going to do things and such. We're still kind of maturing what we're going to do with drivers. Okay. It also houses the host path driver, which is actually used for all our E2E tests in Kubernetes. So if you go to Kubernetes repo and you look at the code, you'll go under E2E storage, and you want to know how is that Kubernetes SI. What we use is the host path driver, which lives in the drivers repo currently. Lastly is we have a very extremely simple in-memory driver in this repo here called Csi Test, and its job is just to be an example basis for running a driver, or at the same time, and most importantly, its job is to be able to test a tool called CSI Sanity, which we'll go into in a little bit. So one of the biggest questions that I get in the SIG storage channel of WGCSI channels on Kubernetes Slack is, where do I save my driver? So I'm going to write a driver. I want to submit it to the drivers repo. And I want to submit it because in OpenStack, I submitted my drivers. In Kubernetes, I used to submit my drivers. So I want to continue this. And the thing is that that's not the answer anymore. The answer is almost always, I want to say 99 by like almost always, create your own repo, create your own community for this. So folks, I'll give you a couple examples. Ceph has created its own section for CSI. OpenStack has done its own section for its Cinder driver, and Portworx, for example, or my company, they created their own driver, right? They're on their own repos. Now, there may be a situation sometimes where there needs to be more of a community driver, one that's owned by, not owned by one company, but owned by quite a few users on the community, volunteers. And at that situation, it may happen that those volunteers are not allowed to work on any other repo other than the CNCF repo. And that has occurred. I mean, it is quite rare, but it can occur. And on those situations, then we'll look into your proposal of what driver it is that you want to work on, and then we'll have a proposal and see if we can include it inside Kubernetes CSI repo in GitHub. So that may help with your legality of working in CNCF project. All right. So now that we talked about drivers, and again, drivers is a very simple thing. It's pretty much left up to you to work on in your own repo. Let's talk about now the utilities that are available for you. There's a couple of utilities. First, there's a repo called Csi Test that houses two utilities. Main utility is that as a client, as a CSI client, meaning Kubernetes or Mesos or any kind of sidecar container or whatever you want, has the ability to test with a mock driver. And this mock driver is automatically generated using Golang mocks, Go mocks. So then you'll be able to automatically, force your driver to respond. So have your client send the command to a driver and have that response come back in the way you want to test it. So it's a very nice utility to be able to test a client. Second thing that we have in CSI Test is a package called CSI Sanity. And this package is made for driver development. So instead, now, like I talked about before, which was as a client, you wanted a mock driver. Now, as a driver developer, I need some type of application that executes commands into my driver. And that's what it's a CSI Sanity package is. And not only that, but the CSI Sanity package's whole goal is to make sure that your driver conforms to the API. That's its goal. Also, we have for another, I mean, not so much of this utility, but definitely a lot of help, is the docs repo. Docs repo is a repo that we have all our documentation on. And let me show you what it looks like. Of course, that doesn't work. Let's see, it's actually here. I need to fix that link. And here is the docs. And it looks like this. So there's a lot of information here. We also maintain our latest releases and such. Okay, so how am I doing on time?
You're still fine on time.
Okay, good. Okay, all right, let's continue presenting. All right, so this is the CSI Sanity tool. Like I said, is a tool to test your driver. Your driver has to be running in some type of mode that it thinks you could either, for example, your driver could mock its backend, so it doesn't talk to a real storage system, but it must provide all the calls to the CSS, and it must provide to make sure that the API runs and the let me see, the CSI spec is conforming to that. So it's definitely not an E2E test. So there was a confusion when some users were using CSI Sanity at first. They were trying to use it as their unit test and then functional test and then E2E test. They were using this, and I tried to say CSI Sanity is not an E2E test. It will not do negative testing. It will not send I/O to your drives. It will not send any of that. It is just an API confirmation test for the spec. It sends a command.
Did we lose Luis?
Yep. Luis, we lost your audio.
I just ping them on Slack, see if he responds.
Yeah, I'm right here. Can you guys hear me now?
Yeah.
Okay,
Yep.
cool. Sorry about that. I guess if things go bad, they really go bad. All right, things keep happening. All right, so okay, all right, so we're gonna client unit test demo, and what I'm going to do here is I'm going to share my code. Here's an example client test demo where I'm going to use this is all for Golang, the client test Golang mock code, of course. So what I'm gonna do here is show you. I'm gonna go kind of fast actually. I'm not gonna go. I was gonna write a bunch of code, but I'm not gonna do that. Instead, I'm just gonna run by. Here's an example that I wrote just a few minutes ago about create volume. Let's say, for example, I want to have a call to create volume for a driver. So the very first thing I do is I call go-mock new controller, create a controller, and then we have a package called, let me show you on the top, mock driver here, and it comes from Csi Test driver, okay? And that's the package you need to include in your test. From there, you can do things like, that doesn't happen. Yeah, do things like this, like mock driver dot new, like identity server, for example, if I wanted to mock that. But instead, we're going to go to do test the create volume call, which is inside the controller server, okay? So then we're going to set up an input, so some request, just enough for the test right now, just a demo, and then an output. In other words, what we're saying is that the fake is going to return back to me this struct, okay? So then we have an expectation here where we say driver, which came from the mock stuff up here. Driver, I want you to expect, meaning I want you to match a function call to create volume. And when it matches this input, for this argument called in, which is over here, then I want you to return an output, right, of out, which is this thing. And I want to make sure that it only happens one time. So then what we do is we call mock driver new CSI driver. This is just a helper function that you register your driver. There it is, this driver from here, expectation. And then you say server nexus. It creates a connection, a true gRPC connection between the driver and the client, which is this connection, CONN, which I have here. Then you can say, I want to make a call. Now this part here, that was all set up. Now you can see down here, it's all as if it was your driver, your client. Your client would have a connection to the driver. He would make the call to create volume. And then here what we say is that we get a response. And then now we have here that R returns an ID, and we have to make sure that this ID is close to my ID. So this is quite simple. And you say, well, my goodness, this is too simple, right? But there are a couple of other examples of using this. So here's two of the sidecar containers using the unit test as an example. So not just that one, which are real examples of real clients. Second is CSI Sanity. So I'm going to show you CSI Sanity on the using the mock driver. So let me go to that and wait for my screen to change. Can you guys see my screen?
Yes.
Okay. For some reason it's not changing on my phone, but okay. Can you see my terminal? Oh, there it goes. Okay. So right now I'm going to, inside Csi Test, we have our own E2E test for CSI Sanity. It's a file called E2E hash. I'm not going to go into it right now. But what it does is pretty much this. CSI endpoint equals, let's see, CSI.suck. and I run the mock in-memory driver. And there it is, it's running. Okay. So then what I do is, let's pretend that's a real driver with a real endpoint, and here's my CSI SOC connection, Unix domain socket to my, maybe I have a 10 terabyte storage system or fake like this. It doesn't matter as long as the endpoint supports the API. So now we can say CSI Sanity as the tool. And right now it says I need to figure out what to talk to. So we can say CSI Sanity endpoint equals .CSI SOC. And I purposely made this happen. So I purposely told it, I want you to return an error. Like, I don't want you to satisfy the entire API. So as you see here, we passed 39 of them. One failed, and on the one that failed, you can see here that it failed because node stage volume, we have it that, sorry, it should fail when no volume ID was provided. So in other words, the test sent a request with no volume ID, and it should have failed, and it didn't. Okay. So let's go to the code, go fix that. Okay. So I took this out before. Let's put it back. So now in node stage volume, we have this function call. It says, if the volume ID doesn't exist, I'm going to return an error. I removed it, I put it back, and now I should kill this. I should say go install.mock, builds it again. I run it again, and I run my test against it, and bam, it passed. So that's how CSI works. It pretty much makes sure that your API is conformant to the CSI spec. Now, what that means is that, that requires some work. If you feel like you want to volunteer your time to make sure that our tests are conformant to the spec, please let us know. We take a pull request. We will look forward to your help and your participation. If you want to see 2 examples on how CSI Sanity is used on real, like Travis or real systems, you can look at the host path driver. It uses CSI Sanity to make sure it conforms to the spec. And you can look at the Portworx driver also, which is it's open source. So you can see how it uses it also. There are actually 2 ways of using CSI Sanity. One is to use the command line model, which I showed you a second ago. And the other one is to pull it in through the code. So I can show you this. In Portworx, what we do is we call CSI Sanity in one call like this. So, and we just execute it right from our test. All right, let's see. Questions? You guys still there?
We're still here. Well, apparently there aren't any questions. If you do think of a question later, please feel free to email the SIG Storage or hit us up on the SIG Storage channel on Slack. As Luis mentioned, we would love to have more tests contributed to this, and Michelle will be presenting on tests in a later episode. So thank you everyone for joining, and thank you, Luis, for your time.
Thank you, guys.
Thank you.
Bye-bye.
Bye.
Bye.